Thanks for watching, and today I want to use the maximum principle to show uniqueness of solutions of Laplace's equation. In particular, let's show that there's at most one solution to its related equation, Laplacian of u equals f in our domain and u equals g on the boundary of our domain. So once again, inside we have Laplacian of u equals f, which is called Poisson's equation, and on the boundary we have u equals g. Now, the beginning is as usual, so suppose we have two solutions. Suppose u and v solve the PDE, and let w be u minus v. And then let's see what PDE w solves. So in this case, Laplacian of w, that's Laplacian of u minus v, that's Laplacian of u minus Laplacian of v, which is f minus f, and that is 0, and that is in your domain omega. And on the boundary, we have w is u minus v, but u and v are both equal to g, so it's g minus g, which is 0 on the boundary. And therefore, what do we get? We get that w solves the following PDE. So hence, w solves so Laplacian of w equals 0 in your domain, and in w equals 0 on the boundary. So once again, inside your region, w solves Laplace's equation, and on the boundary, w is 0. And in particular, the boundary values are very important, because now we want to apply the maximum principle, which, remember, what does it say? If you have a metal plate and you wait for a long time, both the hottest and the coldest temperature are on the boundary. So by the strong maximum principle, max principle, both the max and the min of w are on the boundary. Both max min of w are on the boundary. But remember, w is 0 on the boundary. So what this says is the hottest temperature of w is 0, but also the lowest temperature of w is 0. And the only way where the highest grade is 0, for example, and the lowest grade is 0, is if everyone gets 0. And so, in particular, the max min of w is 0, and really the only way this can happen is if w is 0. So hence, w is 0 in our domain, and now we just use the definition of w. So u minus v equals 0 in our domain, and therefore u equals v. Just like we wanted to show. And in particular, we have shown uniqueness, and really I wanted to show you an example of a maximum principle method where you use the maximum principle to show uniqueness, which again is a little bit in contrast with energy methods, which usually use integrals. Maximum principles usually talk about points. So here are the points where the max and min are attained. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.